Hello students, so I'm your physics teacher Vikal and hope you are doing well. So today we are going to start thermodynamics, a new topic. So first of all we have to understand like what is the importance of thermodynamics, why are we studying thermodynamics, and what are we going to study in this topic, or we can say in thermodynamics. Okay, hello everyone, hello. Yeah, hi. Okay, so first of all, we are going to introduce thermodynamics. Thermodynamics. So by the name, you can see thermo. Thermo signifies thermal energy. Thermo signifies thermal energy. Thermal energy means thermal energy we can say thermal energy is the energy, or we can say form of energy by which we can say temperature. Okay, and heat is the flow of thermal energy. Heat is the flow of thermal energy. Okay, so mostly in thermodynamics we are going to talk about heat. We are going to talk about heat. Okay, so what is thermodynamics? Thermodynamics is a branch of physics. Hello everyone, hello. Okay, so thermodynamics is a branch of physics in which we are going to deal with heat, temperature, okay, and other thermal properties, and conversion of heat into work and work into heat. Okay, so we are going to study about like heat, temperature, okay, and we can say conversion of heat into work and vice versa. Vice versa means work into heat. Okay, concept of physics and chemistry. See, yeah, we are going to study thermodynamics in chemistry and physics both, but some difference is there. Like here, that sign of the work, like when we are going to study work done by gas or work done on gas. Okay, so here sign will change. That sign will change. What sign we are going to take in chemistry? That positive. So here we will take that as negative. Everything, that sign will change. Okay, and most of the things are same here in physics and chemistry, both thermodynamics. Okay, so thermodynamics is what? Thermodynamics, we are going to study about heat, temperature, conversion of heat into work and work into heat. Okay, good evening everyone. Good evening. Okay, and here we are going to study about some laws. Some laws are formulated, which those laws governs the thermal energy. So laws are, we are having zeroth law, first law, second law. So these laws we are going to study. And one more thing, we are going to define heat, temperature, work, okay, accurately, because work we are already have studied in work power energy. That was mechanical work, but here we are going to study what? Work done by gas. Okay, so that work is different. By the way, we can see like that expression for work done by gas is derived by that same formula, W equal to force into displacement. Okay, yeah, zeroth law. Okay, so heat, temperature, work we are going to define. One more thing, like heat and temperature, there is so much confusion. Like what confusion? That means heat and temperature both are same things, but both are not same. Heat and temperature are not same things. Like we say, like if temperature is more, that means we can say there is more heat in that body. That is wrong statement. We can't say that. Okay, so heat and temperature are not same, both are different. So we are going to define heat and temperature correctly, or we can say more accurately. Okay, why? Because historically, when that thermodynamics was developing, we can say, when thermodynamics was developing, so at that time heat was considered as an invisible fluid, and that was called as caloric. Okay, historically, earlier, that heat was called as an invisible fluid, that was called as caloric, but that was wrong. The heat, we can see heat is not a fluid or any invisible fluid. Heat is a form of energy, or we can say heat is a energy in transit. I will tell you what is the difference. What is the difference between heat and energy? Like heat is not energy, heat is flow of energy. You can see thermal energy is what? Here we can see thermal energy. So heat is the flow of thermal energy. Don't get confused between heat and temperature, first of all. Okay, both are different thing. And one more thing, heat is not energy, heat is flow of energy. I'll give you one example. Okay, like when it's raining, we don't say water is falling. We don't say, we don't say water is falling. We say it's raining. Why? Because water is in the way. It is not on ground and it is not in the sky. So we call it by a proper name, that is rain. Okay. Similarly, when an energy is not in any system, when it is getting transferred, or when it is in way, or when it is flowing, at that time we call that energy as heat. Okay, understood? So heat is not energy, heat is flow of energy. So all these things we are going to study in thermodynamics. One more thing, thermodynamics. What is thermodynamics? Thermodynamics is the macroscopic science. Why macroscopic? Because in thermodynamics we are not going to deal with, it is a macroscopic science. Macroscopic science, because we are not going to deal with microscopic, like on, or we can say on molecular basis. हम यहाँ पर molecules के बारे में बात नहीं करने वाले, और we are not going to talk about like what is going on the molecular level. Here we are going to deal with macroscopic properties. Macroscopic properties like temperature, volume, or we can say like pressure. Those all properties are macroscopic property. Okay, so thermodynamics is a macroscopic science which deals with bulk system. We are not going inside, like we are not going to see what that molecule is doing. So it is a macroscopic science, not microscope. Okay, so clear this. One more thing. One more thing. What is the difference between mechanics and thermodynamics? Mechanics and thermodynamics. So in mechanics, like we can say mechanics we have already studied, Newton's law and all. Okay, and thermodynamics. So in mechanics, we deal with what? Forces. What force is applied on the system, or we can say what torque is applied on the system, or we can say we are dealing with the motion of the body or motion of the system. So we deal with the motion of body under the influence of forces or torques. Okay, this was mechanics. We have already studied. Okay, but in thermodynamics, we are not concerned, about motion of system. We are not concerned about motion of system as a whole. We are concerned about its internal macroscopic properties. Concerned about internal macroscopic properties. Okay. So this is the difference between mechanics and thermodynamics. In mechanics, we are concerned about motion of the body, whole body, how that whole body is moving under the influence of forces and torques. Okay, but in thermodynamics, we are not bothered about the motion of the body as whole. We will deal with the internal macroscopic property. Yes, internal means I will tell you. Like in thermodynamics, mostly we deal with a system which consists a gas. Okay, like any gas is there. So this gas will have some internal properties. Internal properties means outside we are not bothered about it. Inside there will be some volume of this gas, there will be some pressure of this gas, and there will be some temperature of this gas. Okay, so these volume, pressure, and temperature, these are internal macroscopic properties. Okay, so if you are moving this like system, like in a container, in a rigid container, you have gas which is having some volume, some fixed pressure, some temperature. If you are moving it with some velocity, so thermodynamics will not change. Because in thermodynamics, we are not dealing with the velocity as a whole of the system. We are dealing with what? Internal macroscopic properties, volume, pressure, temperature. Okay, so if you will change the velocity of the system, or if that system is at rest, these properties will not change because these are internal properties. Understood? So this is the main difference between mechanics and thermodynamics. Okay. Okay, I hope all of you understood. That is the introduction of the thermodynamics. We are not going into detail. One by one, in all the topics we will go into detail. Okay, but for now this is just an introduction. Okay.